Use the points?
Yeah.
How do you mean?
I mean, so just the purpose of finding the domain is just to sketch it, or
Well, one thing it could be is to help sketch it, because then you know what regions not worry about, right?
yeah.
All right, let's see. Let's catch up to you guys. All right, the first A on the 14.2 should have been really easy, right? You get 6. You just plug it as 1 in for x and a 0 for y squared. Part B, the same thing, really. So part B, what do you get? 0. I like it. Because the top, there's x's and y's everywhere. They both become 0. The minus 3 on the bottom saves it from being indeterminate. 0 over not 0 is 0. Right? Part C is the one that freaked a few people out, but yeah, you factor the top. What can you take out?
3.
The alpha x squared minus 9y squared, right?
X minus 3y.
And then you plug in 3, 1. 6 times 3. 18. I like it. So I've been known to throw, cube stuff in there. And I love it when people get really upset at me. How dare you throw x cubed in there for me? Get away from me. Yeah, I just said that. How do you factor x cubed minus 27?
So x minus 3.
Because a little dude's a little dude. You can only put one of each in him. And you got 2 each left. So you put the other 2 of each in the other dude, right? 3 x's, 1 dude there. The other 2 go there. 3 3s, 1 goes there. The other 2 goes there. That's minus, that's a minus.
And then
And then the middle dude is the guy from Pulp Fiction, the cleanup guy.
Plus 2.
The wolf.
3x.
It's 3x because it's going to clean up all the extra shit you don't want. Right? So 1 of each, 2 of each, product in the middle. That's the closest to a song I'll get. Right? Because the more songs you know, the less math you know. I'm sorry to tell you that. There's a little something soap bullshit, but sorry. You know soap?
What?
Same, opposite, always positive.
No.
Same sign, opposite sign, always positive. Right? That's bullshit. Why is that always positive? I mean, it works. Don't get me wrong, it works, but it takes you away from why it works. It just works for you. That's stupid. Why is this always positive? Because that's always the same sign. I don't want it to mess up the sign. I wanted to have that sign. All right, that's always positive. Holy shit, because that's always the same. And this has got to be the opposite sign, so it does its job. What's its job? Clean up. All right, so you start to see why I start to shit on things like FOIL and SOHCAHTOA and this other shit, because it takes you away from the math, the understanding. You feel like you know more than you actually do. You just know songs. Okay. I always get somebody really pissed off at me. Don't touch my songs. I love my songs. All right, whatever. So, what did you guys find out for part A down there, the path problem? What did you choose? Go along follow what path?
Y equals 0.
So that if you do that, you get the limit as x goes to 0 of x squared over x squared, which is 1. And if the other path you're going to use is x equals 0, I love it. People forget the axes. Try the axes first. What the hell? Then you get the limit as y goes to 0 of negative y squared over y squared, which is negative 1. Holy shit, there you go. That's all you need. The limit does not exist because they don't go to the same place. It really is the same thing as 2D. It's a little harder, of course, because you got all these different ways you can do it now. But it's the same idea as in 2D. What about part B?
The parabolic.
Yeah. So what do you guys try? You try y equals 0, you tried x equals 0, that leads to nothing. They both go to 0. Do you try y equals mx? Anybody?
Yeah.
And what happens to that when it goes to,
0 over m squared. Mx
which is
0.
0, okay? So you might have given up, I guess, but like John said, keep going. Try the parabolic approach, right? So it'd be like y equal mx squared. And do you guys see, look at the problem itself. Do you guys see why that might be a good option? Because look at the power on the y on the bottom is squared. And the power on the x is the fourth power. So this path is going to make those match up. They're going to become like terms. I'm not saying if that's going to happen, it's always going to be the right thing to do, but that's the kind of thing to look for to get a clue. Otherwise, you just start trying every damn thing until you get two that don't agree, right? So what happens at the top? Replace the y with mx squared. Get 2x squared times mx squared. We'll just do it one step at a time here. Over x to the fourth plus mx squared squared. Squared. How are we doing there? Is that cool? So I just replaced all my y's with this. And then you get 2mx to the fourth over x to the fourth plus m squared x to the fourth. All the x to the fourths can...
2x to the 4th. It's going to be 2m over 1 plus m squared.
Bam, 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 right? So it's going to be 2m over 1 plus m squared. I like it. Now that's all the work I need. I don't need any of the other paths. Because for every choice of m, I get a different limit. So I've just shown an infinite number of paths with an infinite number of different answers. I think that's enough work to show that the limit does not exist. Do you guys? That's the power of using m times x, or m times x squared, is if I end up being m dependent, sounds like you need to go rehab, but m dependent, that means that my answer depends on my choice of m, which is exactly different answers for different choices of path. Bam! Does not exist. Again, today's the first day we've talked about this, so if it doesn't quite make sense yet, maybe in a year it will. Trust me, it's a little weird to get used to. Yes?
How do you know what to select for the paths? Like, why do you pick mx squared?
Because I'm approaching that point along the most general paths that I can. So I'm going to approach it along the axes. I'm going to approach it along a linear path, mx. Right? And how do I know it's mx and not mx plus 7 or something? Because it's the origin it's going through, right? So if it was going through a point 0, 2, then I'd have to use mx plus 2. The y's got to be 2 at 0. Does that make sense? Do you guys see that what I'm saying? I've used mx and mx squared so far because those ones we did were going through the origin. If I'm not going to go through the origin, I have to use a line or a parabola that's actually going to go through the point I'm interested in. Yes, sir?
So where did you use mx squared with mx?
Oh, well, you guys told me you already tried it. I was going to redo the work. You saw you got 0 again, I think, if you did mx. Is that what you guys said? So if you try mx, you'll get 0 again. You haven't gotten a different result yet. So then I had to go to the square. My point was the powers in the problem kind of have a clue. There's a fourth x power, but there's a squared y power. I can think, how would I make them like terms? Let y be mx squared. Will that always work? No, but it actually will work a decent amount of the time. So that's something to look out for, too. All right, that's enough. Time. Get you guys out an hour early. Oh, well, what's next time? Well, that's what a fraction is. Does it get to 0? No, so it's 0 over something. It's 0. Good question. So you don't, the x never gets to 0. That's why it actually does come out to be 0, not 0. Oh, no, yeah. What did I do? I killed it everywhere. Because you can pull it out of the bottom. And then you can cancel because division is the opposite of multi. You just can't cancel here, and I'm not there because division is like cancel division. I never got my. Oh, did you give it back?